On these word problems, it's a really good idea to figure out exactly what your variables represent. In this particular problem, the x variable, which is on this horizontal axis, is the age of the calf in weeks, and the y variable, which we're calling p of x, which is the vertical axis, is the number of pounds of milk that the calf drinks per day. And we are about to try to figure this out using the quadratic formula. But before we do that, let's let our graphing knowledge help us. We would have to complete the square to graph this completely correctly. But we don't need to do that. We know enough to know that a is going to be a negative number. And wherever the vertex is, and we don't know where the vertex is yet, but wherever it is, let's say it's here, just to have a place. Won't be there, but let's pretend. We know that the graph goes down from there. And what is true at this vertex point? At this vertex point, the x value, that is the age of the calf in weeks, gives a maximum output, gives a maximum amount of milk that the calf drinks. So we can answer this question by kind of knowing the x value that gives us that maximum milk production number. So where is the vertex? Well, we could complete the square. Completing the square on this with all these decimals is sort of messy. I'd rather not do it. There is a formula that tells us the x and y value of the vertex. It's in the textbook. It's in the last section that we studied. But really all we need to know is the x value of the vertex. And the x value of the vertex is the beginning part of the quadratic formula. The quadratic formula goes like this. And if you simply assume that this discriminant is 0, you get the x value of the vertex. So what we really need to know is x equals the opposite of what b is. That's negative 1.3 over 2 times a. I'm going to do that on a calculator. So when I do that, when I do this calculation on the calculator, I find that x equals 3.25. You can see that my picture over here was way off because the vertex is at x equals 3.25 and I don't know how high it is yet. How can I figure out the output of the function p when the input is 3.25 specifically? How can I calculate p evaluated at x equals 3.25? And the answer is you could memorize a formula in the book that always gives you the output of the vertex, but I don't think that's necessary, and for our class I don't think it's particularly useful. Why don't we just put 3.25 into the function and grab a calculator and find out? So I'm going to use a calculator to evaluate the function p when we put in x equals 3.25. And this is what it looks like. Let me try that. So I got 8.3125 pounds of milk, which takes place at about 3 1/4 weeks. And you could round this off to 8.31 or whatever you needed to do. But that is the answer. A couple of interesting things to note. If you go over to Desmos and graph this, you see that the x value of the vertex is pretty close to what we had. And notice also, if on Desmos you put in the function p, and then you put in p of 3.25, it gives you the 8.3125 automatically. It does the calculation of substituting in 3.25 and giving you the answer. That is a way of checking, if you don't have a back of the book answer, checking to see that you press the buttons on your calculator correctly. So Desmos is pretty cool. So x itself is 3.5, and so we have to put in 3.5. We want to know what the cost is at 3.5 hundredths of dulcimers. And so I'm going to calculate this on my calculator. So I find that the value of the function when I put in x equals 3.5, which represents 350 dulcimers, is 1.2, which represents $120. And so the answer to the question is that the 350 dulcimers cost $120, and that achieves the minimum average cost. Let's look at Desmos to see what it has to say. Notice when I put in the function and then the function's value at 3.5, which is the x value of the vertex, it gives me the vertex. It really does. And it tells me the value is 1.2, which represents hundreds of dollars. And we're done. Now this was the cost function. I have a p instead of a c. That's ridiculous, but I just used it from the last problem. So we're done. So it reminds us that the profit is the revenue minus the cost. So I have profit is the revenue minus the cost. It gives us the revenue, it gives us the cost. We subtract and we get this. And so we have the profit function, and that answers the first question. And now we simply do the kinds of things we've done before. Since a is -1, we know that this is going to be a downwards opening parabola. And the function, the profit function, will have a maximum, because there's a maximum height that occurs at the vertex. And so we need to know that maximum height, that maximum p of x value. And that'll give us the maximum value of this profit function. And then we need to know the x that it occurs at, the x value of the vertex, which is the amount of money, it's the amount of product that we need to make in order to get that maximum amount of profit. And so we're going to find the answer to C first, because it occurs at the opposite of p over 2a. The opposite of b is -980, and 2 times a is 2 times -1. And so that is going to be -980 over -2, which is 490. So x equals 490 is the value of x at which the maximum profit occurs. So we have 490, and then what is that maximum profit? Well, we're going to have to put that maximum profit into our that x value that gives the maximum profit into our profit function. And we calculate this function when we put x equals 490, and so I'm going to do that on the calculator. Notice when I copied this formula down, I forgot to put -3000, so I fixed it up and put a -3000 here, -3000 here. When I evaluated this function on my calculator, I got this result. So when x is 490, we get a profit, p of x value, a height on our graph, of 237,100. I chose not to do this on Desmos. I've been doing that. You can do it, but I chose not to. This kind of problem is kind of a standard sort of problem, and that means you see it on a lot of exams and things like that. We're asked to maximize the area of a rectangle. So if we have an area function for a rectangle, if we're going to maximize it, it better be a parabola, it better have some x squareds in it. And if we're going to maximize the function, it better have a top point, so this better be a negative value. And of course we don't know the rest of this, but that's the idea. That's what we're going to look for. So we're told that this is the rectangle, and we're told that we ought to put a W here. So let's put an L here and see what we have. We have that the perimeter is 720 feet. So a couple of W's plus a couple of L's has to be 720 feet. Now we're going to use W for the width, but we would like to write L in terms of W. And so let's solve this thing for L. Maybe we could divide through by 2 everywhere to make things a little bit simpler for ourselves. And we will have W plus L equals 360. Subtract a W from both sides, and we have that L equals 360 minus W. Now it's time to get going on the area function. The area of this rectangle is W times L, but we know that L is 360 minus W. So we have A equals W times 360 minus W. A equals, distributing, we have minus W squared, and then plus 360W. And sure enough, the area formula, just like we guessed up here, the area formula for this rectangle has a minus sign in front of a squared term. So its parabola is going to open downwards. And we're going to find the rectangle that has the maximum area. Normally we write x equals the opposite of b over 2a to find the x value that maximizes our function, but now we're going to find a w value that maximizes the function. Notice, if I wanted to, I could be more specific now that I know the letter that I'm using. I could say that this area function uses w's. So now I'm going to have w equals the opposite of whatever b is divided by 2 times a. b is 360, so it'll be negative 360 divided by 2 times a, which is 2 times negative 1. So that's 180. And that is what we wanted to know. What dimensions will maximize the area? Well, it's when w equals 180. And L, the length, is 360 minus W. And so we have found out that when this is 180 feet and this is 180 feet, that will maximize the area of the rectangle. What would the area of the rectangle be, even though the problem didn't ask us for that? It would be 180 times 180. It would be the area of the square. And so, to answer the question, what dimensions should the rectangle have? It should have 180 feet for the width and 180 feet for the length, and it is in fact a square.